Thank you all so much for joining us today in our panel with our USC CAIS leadership team. I'd like to go ahead and introduce everybody today. I'm Haley Weintraub-Nadell. I'm the Center Operations Coordinator for USC CAIS. Immediately to my left, we have Bistra Dilkina, who is an assistant professor at the USC Viterbi School of Engineering, followed by Eric Rice, who is an associate professor in the USC Suzanne Dvorak Peck School of Social Work, and then Phebe Vayanos, who is an assistant professor at the USC Viterbi School of Engineering, and last but not least, Jordan Davis, who is an assistant professor in the USC Suzanne Dvorak Peck School of Social Work. Eric Rice is the director of USC CAIS, and the other members of the panel are associate directors. Could you please tell us what drew you to your respective field, and particularly to the interdisciplinary work of the center?
I've always been really passionate about the fact that AI combines data with decision making in a way that empowers making more effective and efficient decisions for some of the most complex problems we're faced with in today's world. And in particular, I have been very interested in developing methodologies that combine machine learning with algorithms in novel ways, such that we can more effectively do resource allocation, planning, and large-scale decision-making overall. But AI as a whole is a very large field, and for me, a driving force has been using AI in ways that can inform solving some of the wicked social and environmental sustainability problems. These are areas in which we have very limited resources, very complex dynamics, very challenging problems, and so if we can leverage some of the most effective new techniques that computer science, in particular AI, can offer, that's my dream scenario, and that's what I've been focusing on. Starting with, during my PhD, I worked on the emerging field of computational sustainability, which essentially tried to do that, focusing on environmental sustainability in particular, and now really broadening this at the center of AI in society to working with social scientists such as Eric and Jordan on other problems.
Thank you. And Eric?
Yeah, this is a great question. I think what initially drew me to social work was a desire to work on problems that felt meaningful. I was originally trained as a sociologist, and I was doing work that was very theoretical around social networks and decision making, which was intellectually really exciting, but I felt like I wanted to be involved in something that felt like it had purpose and meaning for my life. And so I got involved in working with homeless youth in particular here in Los Angeles back in about 2002, 2003. So it's been about 16, 17 years that I've been working with them. And in some ways, I feel like I found them by happy accident. I was working in a center where we were doing HIV prevention work with a whole bunch of different populations, and I knew a lot of statistical methods, and so I was tasked with, helping run models basically. And one of the projects I was working on was working with homeless youth, and I wanted to get to know the field better, and so I actually started doing some volunteer work at a homeless youth drop-in center in Hollywood, called My Friend's Place, which is still one of my primary partners to this day. And as soon as I started working there in that space with the providers who are the social workers and with the young people themselves, I sort of fell in love with those young people and the struggles that they were working with, and it felt like I had found a place where this intellectual interests around decision making and risk and uncertainty and social networks and all of these really kind of nerdy intellectual things suddenly had a really concrete place that I could ground them in that felt like I could actually make a difference in the world. And then with the AI stuff, I mean, I think I sort of fell into it by accident. I mean, I started doing some work with computer scientists, particularly Milan Tambe, who used to be a member of our center, back in about 2014. And when I first started doing work around ideas using computer science methods to tackle social network problems, I didn't even realize that we were working on artificial intelligence. I just thought that we were doing cool algorithmic math modeling sorts of problems, and then I got to learn that actually what we were doing was considered to be artificial intelligence and decision making and problem solving. But I was really naive to it, but it was something that seemed really exciting. And as the as the work grew, it suddenly became, I think, something very akin to what Bistra is describing, which is this idea that if we brought together people who thought about problems in very different ways, we could actually come up with new solutions, and we could work on solving problems that seem almost insolvable. I mean, not that we're going to solve homelessness with an algorithm, but things like homelessness and HIV are really, really thorny, awful problems in the world, and if they were easy to solve, we would have solved them already, but they're not. And so maybe part of our problem is that we've become, in the world, very siloed in our approaches to things. Social workers do things the way that social workers have been doing them for 100 years, and computer scientists do things the way that computer scientists have been doing them for, well, I don't know if you guys go back 100 years, but mathematicians have been doing things for thousands of years, so that part of it you've got us beat. And so then, you think about, well, maybe if we brought these people together, us, in a more meaningful way, we might come up with something new that might give us some new traction for these problems. So that's what drew me to this work.
Broadly speaking, my research area is data-driven decision-making, in particular using what we call mathematical optimization and analytics to solve decision-making problems. And in particular, I'm interested in solving those problems that are important for social good. Now, I have to say that much like Eric, this was not a big master plan that I just, I had planned from when I started university or anything like that. I kind of also, by luck, I would say, fell into all this. Basically, to give you a bit of an idea, my background is in electrical engineering. Electrical engineers solve a lot of optimization problems, but I had never in my undergraduate studies experienced this idea of solving, decision-making problems that we are faced with every day, right? I used optimization to solve like engineering sort of problems. One day I was in this quantitative finance class of all places, because quantitative finance at that time was very, very hot in London. I studied in London, so everyone was taking quantitative finance. And the professor there started talking about Markowitz portfolio optimization, which you maybe have heard of. It's a mathematical optimization problem that is very efficiently solvable, and that solves the following problem. How should I allocate my finite budget among different assets that have different risk and return characteristics, right? What is the best or optimal way for me to do this so that I maximize my return while not facing too much risk? And that lecture was, I think, for me, the defining moment when I thought, oh, this is the coolest field ever, right? I'm like, this problem that seems like very hard, that all of us are faced with, suddenly I can model it with math that I love, and then I can find a way to I need to think at the same time whether this problem that I formulated in this smart way, can I solve it efficiently using a computer? I felt that kind of all the things that I liked came together. And so I guess at that point I started thinking, well, maybe I should do like finance, right? And so I went into a PhD, which started by me working in finance, and I really was very excited by like the kind of problems that I had to address from a mathematical perspective. I thought they were very challenging. They had this idea of like trying to mitigate risk, but somehow I didn't really feel fulfilled. It was rewarding from a kind of in the mind, like, but it wasn't rewarding in the heart, right? I didn't feel that I was happy doing what I was doing. And so later on during my postdoc and now having come to USC, I feel very fortunate that I have found a way that I can not only work on these mathematically challenging problems, but also where I feel rewarded every day by knowing that I've solved an important problem. I'm very fortunate to have found all of these guys. and that we're doing truly interdisciplinary work, because I would say that even during my postdoc, I helped work on important problems from a social perspective, but it was never truly a collaboration. I was partnering with organizations. Now I really feel that every day I learn something from these guys, right? We've been working now even with Eric for at least 3 years now, and still I feel like I'm learning from him every day. So yeah, that's it.
And Jordan?
Great, thanks. I feel like I'm learning from them every minute that I hang out with them. So thank you for that. So my work, very briefly, surrounds the study of the development of substance use disorders and the treatment of substance use disorders among at-risk youth. And I came to this field, much like most of the panel, I fell into it. My advisor had done something similar, and he said, here's some data, write a thesis. And I did it. I didn't really think anything of it. And as I kind of moved through my career, and as a matter of fact, very recently, I've actually had to think back, why do I do what I do? And it was not until the very recent passing of my grandmother that I thought, why do I do what I do? Like, why is it that I care so much about at-risk youth? And I was at home hanging out with my family, and we were talking about it, and we all came to the conclusion that my grandmother, while growing up very poor and with a dirt floor, was a social justice warrior. She would do anything for anybody who needed it. If you needed $10 and all she had was $10, she would hand it to you. And we started really thinking back about this and thinking, well, maybe we that was sort of ingrained in our DNA over, generation after generation. And as I started moving through my career, my focus started moving more towards not just those with substance use disorders, but even those that have experienced a lot of early childhood trauma, a lot of adversity per se, and in particular those youth who have developed a disorder called post-traumatic stress disorder. And this is a group of individuals who are sometimes forgotten in the substance use world, because a lot of folks focus on what are you using and how do we get you to stop. And what my research looks at is kind of the opposite. It's how do we treat the emotional dysregulation? How do we treat the traumatic events to then hopefully eventually get them to a point where they're not utilizing substances in some sort of self-medication or co-use manner. And when I came to USC just a couple years ago, Eric, I'm not even kidding you, I don't even think I had been in my office for an hour. Eric walked down to my office and he said, hey, do you want to do some cool stuff with computer scientists? And I was like, okay, sure. I don't really know anything about computer science, but yeah, sure, let's do it. And so they invited me, they kind of invited me to some of their talks, and really, really quickly, Bistra, Phebe, Eric, and I really bonded. And when I say I learned something from them every single time I'm with them, I'm not kidding. I think in the last 2 years, I've grown more as a hard scientist than I have in my entire life. And they've really helped move my career forward, and they've also helped me integrate what I consider the next generation, and more so where the field of social science and even addiction psychology is going, which is big data, which is AI, machine learning. And our field is very, very new to it. As a matter of fact, I don't even think most of the folks in our field are utilizing these methods, and they're really, really helping me kind of introduce that to a field that I think could really benefit.
Awesome. That's actually the perfect segue to our next question. Eric, how does USC CAIS fit into the ever-growing field of AI for social good?
Great, ask me the easy question. Sure. So I think USC CAIS fits into the larger space of AI for social good, maybe in a couple of different ways. I mean, first, we were the first university initiative that was a interdisciplinary center that explicitly thought about doing AI for social good. So back in 2016, when we founded the center as something that was both in the School of Engineering and in the School of Social Work, very intentionally in the two spaces, we were thinking about, if we're going to do AI for social good, it shouldn't just be computer science and maybe working with community organizations, or it shouldn't just be people in something like social work who are using kind of antiquated, maybe out of the box machine learning tools or something like this, but we could actually do something much more innovative and inventive if we brought those computer scientists and social work scientists into one space together. So I think that is the other piece that really, I think, maybe is important for people to think about CAIS, which is that not only was it an early innovator in terms of thinking about bringing these two fields together, but I still think that it is probably unique around the country still, in that we have these different fields represented as equal partners. I mean, it's not by accident that there are 4 people representing the two sides in equal numbers sitting up here. I think that's very intentional by us, that we want it to be an equal partnership. And I think the other thing that we're doing that's really different and innovative and sets us apart is this focus on the optimization and resource allocation and planning sorts of AI that really both Bistra and Phebe have spent their careers doing. I think within the social science space, as Jordan was mentioning, there is some interest in people using big data and machine learning and doing some things that are about predictive analytics. So for example, in the space of child welfare, they're looking at, can we predict which families are going to be experiencing abuse and neglect of children, and can we try to do some early intervention? And that work is really great, but at CAIS, we're interested in doing things that are a step deeper than that, where we're not only trying to figure out, can we use past data and data mining ideas to make some predictions about what might happen, but then given those predictions, can we also create algorithms that do resource allocation and planning that are more intentional, so that we can use the scarce resources that are available to social service organizations in really intentional ways. Because I think one of the challenges that we face as a society, at least in the United States in particular, is that our social welfare system, is pretty under-resourced considering the size of the country that we live in. There are nations in Europe where they invest a lot more proportionally in their social welfare systems. And so there's a lot more resources to go around. And so you don't have to worry about being as efficient and making sure that you're using your resources as well as you can. But here we really are with resource constraints. And so I think the work that we do is particularly important because we're in a country where there's just a lack of resources for these social service programs. And if what we can do is to create some solutions that use that same level of resources, but in more effective ways, that's a huge gain for our country and our society. And I know that's a big ambition, but I don't think that it's an unrealistic one either.
And Phebe, could you please share from an engineering perspective how you feel the center fits in to the AI for Good world?
First of all, I feel that we are very unique in the sense that we had started addressing such problems even before we became a center. So Eric and I, for example, at the time when we launched the center, we had already been working together for a year. So somehow our collaboration happened very organically rather than just like imposed from the top because we are a center. We found out that there's so many problems that we are both excited about, right? One of them is housing allocation for those experiencing homelessness. This is an issue that we were both very interested in and that we started working on before we became a center. Similarly, we have another project we're looking at which is concerned with suicide prevention. There again, this happened before. So somehow our collaboration was very organic, and I think this may not always be true of such centers. Something else that comes to mind is that from the engineering perspective, I feel that taking your research all the way from the lab to the field is something that not many research groups do. And so I feel that this really puts us in a very special position relative to other research groups. I really get very excited that we have this opportunity to not only do the new methodology, work with the real data, etc. Many people do that, and I love doing that. But I also love that all this hard work that we did to develop this new algorithm, this new methodology, we can really see make an impact in reality, right?
Thank you. Moving right along, Jordan, could you please tell us what advice you have for college students, master's students, doctoral students who are interested in interdisciplinary work?
Advice. I think if someone is really interested, regardless of what side of the coin you're on, whether you're on the CS side, the engineering side, or the social science side, getting involved in the actual field work, I think from both perspectives can really, ignite a passion or even just ignite sort of questions that need to be asked and answered. I know Eric does a lot of field work here in LA. He's been here over 20 years, I think, at this point. I'm brand new to Los Angeles, and I know when I'm in the field meeting with board members of specific organizations, I get really excited about finding ways to help them solve their problems. For example, we just met with CHLA, and it really seems as though they have an issue right now with getting individuals into treatment and keeping them into treatment, specifically among youth in treatment for substance use disorders. And this is a conversation that just happened, but has really started me thinking like, okay, so how can we help? How can we find ways to help them engage their youth so that they keep coming back? And I know Eric and Phebe are working on some really great projects with housing allocation with homeless youth. And if you're interested in interdisciplinary work, come out in the field, get your hands dirty, understand why the problems are occurring, like understand what's happening in the field so that you can really have, at least for me, it at least gives me a reason to do what I'm doing and not just sitting behind a computer, typing code or writing a paper. It's because, you get to meet with the clients every week. You get to meet with the organizers in the organizations, and you can see the change actually happening in the field.
Can I throw in a piece of this
Sure.
as well? Because I think the other thing, aside from getting involved and getting your hands dirty in the work, which I think is really a key part of it, it's also, I think, if you want to do interdisciplinary work, you don't have to be an expert in social science if you're on the computer science side, or vice versa. But I think, especially if I were an undergraduate, I would encourage thinking about taking classes not just in computer science or not just in social science. I think part of my ability to talk to folks like Bistra and Phebe has really been facilitated by the fact that when I was an undergraduate, I was a nerd for math, and so I took a bunch of math classes just because I thought that they were fun to take. And I think that's probably not the way that most people think about math classes who aren't engineers. Most social science folks don't necessarily think that way, but it makes it so that you can have some conversations with people that otherwise speak a different language. I mean, I remember teaching a class about 2 years ago that was an AI for social good class that I was co-teaching, and there were CS students and social work students who are PhD students, and I asked the computer science folks to raise their hands if they'd ever taken a social science class. And I think that 2 of the 20 who were from computer science had ever taken a social science class, even as an undergraduate. And when we did the same thing with the social science folks, there were about 10 of them, asked them if they'd ever taken a computer science class. 1 of them raised their hands. And so one of the things that we saw with those PhD students at that level who were interested in this interdisciplinary work was that they spent most of the semester just trying to figure out, what is this other person even saying to me? Because they spoke such different languages. And so I think, one piece of advice for especially people at an undergraduate level is, take Psych 101, Psychology 101, or Sociology 101, or a basic computer science, programming class, or take that third semester of calculus that's not actually required. Because I think that a little bit more math or a little bit of social science, even if you don't do more than what's for an elective, it'll at least give you an exposure to some of the basic ideas and the basic language, and then you'll feel much more confident having the conversations with the other folks. Because I don't think it's that without it you can't do it. I think it's an issue of confidence. I think that when people are having that communication breakdown, a lot of it is just because you learn so much so quick in university settings about the specifics of your field, and you become an expert in that so much faster than I think you even realize, and you get really comfortable and confident in that expertise. And then when you're faced with somebody else who has a totally different set of expertise, suddenly you feel really kind of dumb. I mean, I think Jordan and I joke every once in a while about how dumb we feel when we talk to Phebe and Bistra, because we're like, did you understand what they just said? And it's like, we'll look at each other like, what did they just say? I don't know. I don't get it.
We feel the same.
But then we also end up, but we've also learned over time, and we have enough confidence at this point in our careers to turn to the other one and say, okay, could you explain that to me, please? Because I know maybe it's a really basic question to you, but to me, that's something that I've never heard of before, and that's a really important skill to have. And maybe, if I can imagine if I feel uncomfortable doing that at 46 and having been an academic for 20 years, I can imagine if I were 22 and I was a first-year PhD student, I would be totally intimidated by that.
Bistra, do you have any other brief advice for students who are interested in interdisciplinary work?
As opposed to advice, maybe highlight some of the benefits of interdisciplinary work. So a lot of what Eric was mentioning about this communication breakdown, I think working on interdisciplinary projects, one of the biggest benefit is learning how to speak to people outside of your particular silo of expertise. And I hope we are learning to communicate our expertise better and better as we talk to Eric and Jordan. So maybe this is going to happen less often, but that's, myself as a PhD student, when I was working on projects related to using AI for conservation planning, that's one of the things I felt was one of the most useful things, is I had to sit in a room together with people that were ecologists or biologists, conservation planners, and in the beginning, I kept on asking them, so what are the decision variables? And they don't understand what decision variables mean, or what an optimal means. And just learning how to talk to them in a way that communicates what I am trying to model or to understand, and at the same time, try to understand what they mean and learn how to ask questions so that we drill down to a place where I can actually translate what they're trying to do on the ground into a mathematical model in my head, and then explain it back to them in my own words in a way that they can understand. That whole back and forth is such a huge learning experience, and it's something that you take away with you to whatever job you're going to go to after working on your master's or PhD or even undergraduate research. Is extremely useful, and so that's one of the biggest benefits of working on interdisciplinary projects. In addition to all the obvious ones, like you're solving important problems, you're making an impact in the real world, etc. But that communication thing nobody can give you if you just stay in your own discipline.
Could you tell us how you see AI being used for substance abuse or substance use prevention and treatment?
So as of now, we have just a few projects that are just sort of getting underway. One of them is very relevant to what's happening in the world today, and we've taken some machine learning models called random SEM forests, and we have used it to help find the best predictors across male and female patients in treatment for opioid use disorder. And this is results that we literally just finished up a couple days ago, and we're really excited about it because we have so much data out there on maybe predictors of initiation, predictors of actual usage over time, but very few papers have used this type of methodology when predicting what I consider an important variable or important outcome, which is latency to use. So, the time to use post-discharge for treatment. And this can be These models can be used to help inform what we call booster sessions. So if you leave treatment, we don't just sort of brush our hands and say, well, good luck, let us know if you need anything. This would be used to say, okay, if you have this profile, here's the probability that you're going to have a quicker latency to use. So maybe we use sort of a what I like to call the dentist checkup model, meaning you go to the dentist, well, you're supposed to go to the dentist every 6 months. Maybe whenever someone leaves treatment for substance use disorder or treatment for PTSD, maybe we just don't brush our hands and say, good luck, let us know if you need help. Maybe we have actual follow-ups with them to sort of do resource allocation. Say they need help getting a job. Maybe they need help, or maybe they need assistance with some other sort of issue going on in their life. The other area that I think AI and machine learning can help is something that Bistra and I are working on right now, which I'm really excited about. So a lot of my work now has been sort of transformed into the veteran population. And there are a surprising number of veterans returning with PTSD, and some sort of substance use disorder who are not receiving any treatment whatsoever, either because they can't or they have some sort of stigma that they believe surrounds receiving treatment. There's a lot of reasons why someone wouldn't seek care. But one thing that Bistra and I are working on right now is ways to collect data passively. Meaning we can take all of your cell phones right now and we can just start collecting tons and tons and tons of data that can be used to help predict maybe when somebody might be experiencing symptom escalation of PTSD or a substance use disorder. And then we can use that data, well, let me rephrase that. Bistra can use that data to help predict when somebody is going to be needing an intervention at the exact moment before something like a relapse or before they become so dysregulated that they go and they use whatever their substance of choice is, or before their PTSD symptomology becomes so overwhelming that it affects different parts of their lives. So I think AI and machine learning, at least in my world, has a lot to offer. I'm just really hoping NIH sees the same benefit and sort of starts funding some of these projects, because I really think we are on the cutting edge, at least in terms of the addiction psychology world, of providing those sort of models and providing those what we call just-in-time interventions for individuals that are most in need.
Bistra, I'd love to hear more about your disaster preparedness and community resilience related projects.
Yeah, so as I mentioned earlier, I have a lot of focus on using AI for environmental sustainability and nature disaster planning. And so currently we have a project which is focusing on using AI for mitigation planning against natural disasters. So for example, places like Los Angeles and many other places across the world and even just in the US have been exposed to increasing number of large disasters like flooding or earthquakes or hurricanes and so on. And so it's extremely important to make our infrastructure more resilient to these disasters and henceforth also our communities. And so how are we going to do this? And even proactive cities like LA, which has a resilience plan in place, have limited resources to do such interventions. And usually you have these large-scale transportation networks, water infrastructure networks, and so on. So where to invest the limited dollars into fortifying some parts of these networks is a very difficult combinatorial problem. And so we are working with the Department of Power and Water in LA to try to inform a project which is basically trying to take part of the water infrastructure in LA and replace it with special pipes which are going to be resilient to earthquakes. And the goal is to try to make sure that this is done in a strategic way such that some part of the water network is actually going to remain functional even in a large earthquake. And that in critical customers such as evacuation centers, hospitals, schools, fire departments are actually on that network and will have access to water that they will really need in this situation. So you can imagine there's miles and miles of pipes and many different options that can be picked. So that's why the problem is so difficult. And so we are getting data and combining that with optimization algorithms to try to help them. And so that's just one example. There's many other sustainability related projects we are working on. As I mentioned earlier, I'm very passionate about using AI for biodiversity conservation. As many of you might know, biodiversity is a huge risk. Extinction rates are rising, mostly because of urbanization, deforestation, and just generally land cover change. And so making sure that we can help agencies that are trying to protect biodiversity, and again, in a data-driven decision-making algorithms is important. And so I have several projects looking at how can we utilize algorithms to help in creating decisions about conservation reserves, about wildlife corridors, about patrolling protected areas against poaching, etc. And all of those, again, require this making decisions in large spaces with limited resources.
Okay, I have one final question for the panel, and that goes to Eric. What do you see for the future for USC CAIS?
What do I see for the future of USC CAIS? Thanks for the easy questions. I would hope that this center could be a focal point for this kind of activity, so that my hope is that there's going to be other faculty and many more students who want to get involved. And then I feel like the potential for this group and this kind of research is really big. I mean, I don't really know what I could see the limit to it being. I think that really in some ways it's just limited by our imagination. Like, can we actually think of, as we think of these social problems that are so vexing, or these environmental sustainability problems that are so vexing, and can we start to think about them in ways that are where we can think about formalizing them as math problems that computer scientists can tackle. And there's the really kind of I think in some ways the sky's the limit about where this could kind of go. At the same time, do I think that an algorithm alone is going to solve homelessness? No. But could we potentially, by designing a much better housing allocation system, help to improve the lives of, even within a city like Los Angeles, thousands of people? Yeah, and that's a pretty exciting thing to think about when you're doing academic research, because I think a lot of times within the space of universities, we think a lot about teaching classes and publishing papers, maybe winning grants, but the real social impact that drives everyone who's been talking here this afternoon is not something that's always there. And I think that, to me, what I would love to see is that CAIS is seeding ideas and inspiring people to genuinely make the world a better place, and hopefully in some large scale ways in some projects, but even if it's just in small ways, that's great, I think.
Are there any questions that we have from the audience?
So I was wondering if there are any important milestones within the center that you guys were particularly proud of. This goes out to any of you guys, maybe a certain project or implementation of research.
So I think one of the things that Phoebe referenced early on is that the center began with some organic collaborations between people in social work and people in computer science, and engineering in general. And so one of the important milestones was actually in late 2016 when we actually started the center, and we said, hey, there's a group of us that are doing this stuff that other people aren't doing, which is this interdisciplinary social science engineering thing. Let's make a space, a home for us to do this work. And then as soon as we did that, there was a flood of students that started coming to us to work with us that there hadn't been before. And one of the things that was actually really exciting about this, and this is actually reflected in the audience here this afternoon, is that we actually started to see, especially in the computer science side, a lot more women who were involved in science and technology, who were coming into the labs that we were working in. And that was a really cool thing to think. So there was something about this particular version of engineering and social work that was appealing to women in science and technology, which I thought was really cool. And then I think one of the other milestones for us, I guess, is as we've had specific projects, as they start to get implemented in field tests, that also becomes a really big deal. So there's an HIV prevention project that we just finished doing a big field test of in the spring. And so that felt like a really important milestone. I think there are milestones that we're looking forward to around field tests around other projects that I think will again be these real world proof of concept things that Phebe was talking about and that Bistra was mentioning as well, is that, you've got in this center, we don't just do math models and computational experiments, but we also actually try to go out and do social science field tests of these things. And those moments when we actually hit the ground, hit the real world and start doing those things feel like milestones. And when we finish those things, it feels like milestones. So, there's a lot of stuff that I think of as milestones, but I don't know that there's anything that I would say, and this is probably a worthless thing to say on camera, but it's not like we're when we get this big grant, then we've made it. I mean, I think we think of ourselves much more in the space of, we want to make a difference in the world. So I think that if we get a program, I think I would really be like, this is a huge milestone for us when we get to a place where there's a program that's out there in the world that's implemented at some scale. Like the HIV prevention one, we did it with about 1,000 youth. That felt pretty awesome. That's a lot of young people to do HIV prevention work with, right? But, if we were to do another project like the one that Bistra was mentioning with the city, and they actually did lay pipes to protect the water resources because of an algorithm that she designed, that would be a huge milestone. I mean, if the LA Housing Services Authority that we're working with around this matching algorithm actually uses our technology to place people into housing, that's going to be a huge milestone. I think that those are things that are real milestones for us to look forward to. And that's the kind of stuff that I get excited about, not whether or not we won another grant. That's important. I mean, we need grants to do our work, right? We need their resource constraints, even in academic work, right? But the reality is that stuff doesn't get me excited. What gets me excited is actually seeing things happen in the real world because of what we do.
For me, I'm very excited about this coming year. I feel like we have at least 2 or 3 algorithms that we want to deploy in the field. And so one of them is, for example, suicide prevention, where, we have our first algorithm to address this problem. And, we hope that we can deploy it perhaps here at USC and hopefully see positive outcomes.
One, I guess, thing that has happened that I also feel is very important is also propagate this idea about really thinking about how to use computer science and artificial intelligence for social good and putting that in the minds of more of the younger generation, as opposed to just focusing on the techniques, right? And thinking about I'm gonna go in the industry and work for one of the big tech giants and my path is laid forward, right? So for me, in terms of kind of educational outcomes, is also a very important thing about raising awareness that, when we are studying these techniques, we actually have many different career paths or paths in general that we can follow. And so some of that has, in a sense, manifested itself in, several of the undergraduate students here at USC kind of coming to us and saying, hey, we saw that there was this graduate class on AI for social good. We would really like to have a class like that and learn about what AI can do in the field and in social good. And so now we are teaching this class for a second time in a row this fall. And for me, that's a milestone in terms of actually, hopefully these undergraduate students will then go on to become these global citizens that are going to use their CS degrees to do social good in wherever they are. Not only graduate studies, but in their work or in the communities that they join later. So.
Thank you all for your time.